welcome to Great Minds Tutorials. This is your favorite tutor, Khodiso, and this is part number 4. And in this part, I'm going to be explaining what we are calling a linked list, but I'm going to be explaining it as part of the collections. In the previous episode or previous part, I've explained it in terms of collections, that an array list is under list. And now in this case, I'm going to be explaining a queue. So just come here, Java. Then I'm going to say linked list example. So remember, a linked list can be either a list or a queue. So, but in this case, I'm going to be explaining it as a queue. Okay, let me first explain it as a list. So let's say I have a list of numbers. So I'm going to have an integer in here. It's my data type, numbers, new. And then I'm going to say linked list. Just like that. So and then I'm going to put in a linked list. And then I'm going to add a list. Made a mistake here. Supposed to be like that. Okay, now, so yeah, I have it. Let me have another one. So I'm gonna queue, and then let me have a string. Let me repeat names again. New linked list. According to the collection, you can have both a linked list as both a list and a queue. It's possible to do that. So now this is just you declaring a linked list, and you can add data into a linked list. So same as a queue in a line. Let me open Paint quickly and explain something. I'm gonna do a very simple example. Very simple. You're in a queue. From the word queue, you're in a queue, there's a counter. Let's say you're in a bank. There's a banker here. And you're in a queue. You're standing in a queue here. You're the first one in the queue. There's someone behind you in the same queue. And there's another person behind that person in the same queue. And there's another gentleman behind in the same queue. So when services are being rendered by the teller in the bank, the first person who got into the queue is the first person who's going to be served. And that very same first person is the first person who is going to leave the bank. So we're dealing with something called first come, first serve. So, but in terms of Java, we're calling it FIFO. So what does FIFO stand for or represent? It represents what we call first in, first out. Simply as that. The first person to enter the bank, be in a queue, the first person who's going to go out of the bank. That's what you must remember. So now when we get here, that is what a linked list is going to start now implementing to you whenever you're now dealing with a queue. So now in order for us to add into the names, we can say names dot, then we can add. And then we can add the first name again, favorite tutor, Khodiso. dot add Kelvin. Tom. Okay, let's do something called parallel arrays, linked lists, or parallel linked lists, similar to parallel arrays. Let's have ages here. Then here, let's add their ages. Dot add. We don't want to add as a specific index. We just want to add. So we're going to add the first. Oh, no, this is an integer. Let's say 27. Random ages, 34. Random age, let's say 56. And that is what we are doing. We are adding into both of them. So now we can display also display easily also by saying system.r.println. Can say names, system.r.println. We can also display the ages. That is going to be able to show you the names, all of them, and underneath is going to show you all of the ages, like that. All of the names, and underneath that showed you all of the ages. So that this is parallel. Hodiso gets the age 27, Kelvin gets the age 34, and Tom gets the age 56. Just like that. Right, now, once we have that, that is how you can simply display. Then you can still be able to say for int I is assigned to a 0, and then you say I, you can take any of them. You can take names, dot size, and you can say I plus plus. Why can you take any of them? Because they are similar in length. They have the same length. Why? Because they are parallel to each other. So the first linked list has got the same size as the second one. So now when we get here, we can say system.out, but I like doing this. I like going out here, putting in a string here, which is disp. Have it as an empty string. Then here I can say disp. Inside here I can say disp is assigned to disp dot concat. And then I can say the name of the person, number, concat. I'm gonna say I plus 1, concat. I'm gonna say is concat. And then we get their name. And then we're gonna say names.get. All right, now, so here is another thing you must look for. So we are no longer using get. Reason being is because now we are implementing what we call a queue. So now let me do this. When we say ages dot get, you see? So now for the ages, we can use get. So here is the thing you must look out for, and I almost made that mistake myself that you can be subjected to, is that now remember, an ages is a list from the collection, but the names is a queue. So for a queue, you have what we call a pool and a peak. A poll, a poll, it's PWOL. So depending on how you want to. Okay, so now we're gonna say names dot So as you can see here, when we get to this one, it says that it retrieves but does not remove the head of the queue, meaning that the first, it retrieves but it does not remove, which that one is your element. And same as peak, let's come to peak. So it says peak, it retrieves but does not remove. Element, it retrieves and does not remove the queue from the queue. But poll, it retrieves and removes. So there are three types of ways that you can get. It's an element, a peak, and a poll. A poll, PWOL. So PWOL, you can use that to retrieve. But once you retrieve using PWOL, it's going to take it, but it's going to remove it from the list. It's no longer going to be existing in the list. But this one, what it does is that it's going to remove it, but if it doesn't, if it finds that it's empty, then it's going to return a null if it's empty. But for the element, what it's going to do is that if it finds that the list is empty, it's going to return to you what we call an exception. We have done exception handling before, and you should understand what exception are. So it's going to return a no such element exception to you, which you need to handle in any way. So now element, peak, and poll. So now let us demonstrate them. So if I were to say dot element, that should be able to give me the name of the first person. Then concat, we want to go to a new line here. Concat, go to the new line. No. I'm a little bit ahead of myself. Okay. Yeah, and we see their age is, we write their age. And then we're going to concat. Then now when it gets to ages, you have to use it as a list. So you'll see, even if you try and say Paul, it was not going to exist there. Why? Because from the collection that we're taken from, we are saying that this linked list is a list. It's taken from the it implements the interface which is called a list. But this one, it implements an interface which is what? It implements an interface which is a queue. So one thing you must understand that you must also look out for is that in the previous part, whenever we are explaining, is that I think it was part number 3, part number 4, we're explaining the array list, and this is part number 5. So in the previous parts, whenever we were explaining, we once touched on something called a generic. So how do you see that this is a generic? Is because inside here it has got this kind of brackets. But I think we haven't discussed generics. We are still going to discuss generics, but I'm going to pre-introduce you to what we call generics. So I'm going to go in depth into generics as soon as I'm done with my data structures. So you're going to start seeing what we call generics. So inside this kind of brackets, whatever you're writing, you're saying that that is a generic interface. So you will see by the fact that you are sending what? The data type, meaning that you can use the same queue for an integer, you can use the same queue for a string data type, you can use the same queue for a double data type, for Boolean, and so forth and so forth. That is how you represent a generic. So now, okay, yeah, when you get here, you need to use get. You need to say get at specific I. So, okay, now once we have done that, we have accumulated everything for the whole for loop. Then now we're going to system.out one thing, system.out print line, and yeah, we're just going to show this up. So now, immediately after this, I would like to go to a new line. A new line. Okay, so as you can see, it says the name of the first person is Khoriso. Their age is, oh, I forgot to write age, but I had it in my mind. At least their age is, okay, yeah, let's go skip another line. There we go. Now it should be able to say the name of the first person is Khoriso and their age is 27. The name of the second person is Khoriso. Oh, something is not. Oh. Okay. Now, here is the thing. It almost got me. Okay, now, what is happening is that, remember, element, it gets the first person. Yeah? So now what we need to do here, specifically, if you want to show all of them, okay, it's right. If you just use element, what is basically going to be doing is just going to say Khodiso, 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 because why Khodiso is still the same person on the list. So if we want to work like the queue that we drew here in Paint, which is this one, if we want to get Khodiso, this guy, the tutor, if we want to get him, okay, yeah, this is what I'm looking for. If we want to get this guy, which is Khodiso, and then remove him from the bank so that he leaves the bank, and then this one becomes the first one, we need to use what we call Paul. Paul, P-O-L-L. This guy is going to take Khodiso, represent him, that here is Khodiso, he was first in line, he was helped, he's out of the bank. So same as the linked list, if we get here, but look at something before I go back and re-explain that. The get, it's able to change each and every time. See? But Khodiso is kept straight. Why? Because it's a queue. In a queue, you need to know element, a pull, and a pick. So if you were to use pick again, still going to be able to do the very same thing. It's going to show you Khodiso, Khodiso, Khodiso. Let's save this and run. You'll see it's going to be the very same thing. Still doing the same thing, still showing you Khodiso, Khodiso, Khodiso. And I didn't spell my name right here. How possible is that? Okay, now it's fine. Okay, now, yeah, in order for us to remove, we need to use this. Paul. So you'll see now it's going to say Khodiso, Kelvin. Then, here is the problem. Now it's going to get to the last one, and then it's going to stop. So what is happening here is that it will only be able to access the first two, which is Khodiso and Kelvin. When it gets to the next one, it won't be able to remove the last one. Why? Because it is the last element which is found inside that linked list. All right. So that is the only limitation that we are having with that. So now, depending on whether you're using it as a queue or you're using it as a list. So this should come in handy. Why? Because it should be able to tell you that, okay, it's going to depend on what I want to do with the linked list. Then you're going to decide whether you're going to make it a list or you're going to make it a queue. Hope that makes sense. So this is the guy who was last. The last person to be first in the queue is Kelvin. Hence, whenever you run, it only runs up until Kelvin. So, but if you were to do all of this, and then immediately after this, you display names, you will see it's going to show you who is remaining there. See, Tom is left. So it has removed this guy, it has removed that guy, but who is left? Tom was the last guy. Hence, Tom cannot be displayed this time because Tom is the only one who's left, and it's no longer a line. It's no longer a queue. Why? Because Tom is left alone. So when he's now left alone, it's no longer a queue. There's no one before him, and so forth. So whenever you're using it, think of it that way. If I am writing a linked list, which is the second data structure, do I want to write it as a linked list, or I mean as a list, or do I want to implement it as a queue from the list of my collection interfaces? So you need to decide on both, but I'm glad that we did both. So that is for the displaying part. Let's see some other stuff that this should be able to do. You should be able to check if it's empty. You can say names dot is empty. Standard, I've done it before. Is empty is just gonna give you a true or false. So meaning that we can be able to do this. That I can be able to check if this is empty. Control X, Control V, enter, Control S, save. Okay, false. It's not empty. That is the other thing that you can do. So you can say names dot, let me see. You can clear also. When you clear, as soon as you display like how a list works, is that it will be empty. In this case, it's going to remove everyone. Okay. That is the other way. Names dot. So if you want to we have done pick, we've done poll. You can remove, which is going to remove the head, and remove and poll, they are working the same, but remove is going to if it's empty, then it's going to catch an exception. So let me do this. Let me remove, but before I can remove, let me first clear so that we can catch that exception. Okay, do that. So if I do that, should be able to catch this exception, which means it's no such element exception. That is the exception that we are getting. So you should be able to catch that exception. So now, okay, if we remove this, it's gonna be able to remove properly. And same as Paul, as I was explaining, it's gonna do the very same thing. If I were to say names dot clear, if I clear before so that it's empty, I'm gonna catch an exception. Okay, but did it clear? Save. Let's do this. Okay. But it's supposed to catch an exception. Oh no, that is element. The one that is supposed to throw an exception is element. There we go. Yeah. So it is element and not Paul. So, but let's see what other thing can you do here. Names dot. We've done is empty. We've done elements, remove. You can also check the size. And that is primarily what we're going to be using commonly almost every time. And that is it from me for this episode. Until we drop the next one, please remember to like, share, comment, and subscribe. There's many more stuff that we're going to be doing after this data structures, but there's a few data structures that I want to show you before we can quickly go and do our generics. And that is it from me. So the next one. Cheers.